Well, good afternoon, everybody. This is Dave Jones with Storm Center Communications and GeoCollaborate. It's Friday, November 8th, 2024. We've made it to the weekend, and we still have Hurricane Rafael out there. This update is for the All Hazards Consortium Sensitive Information Sharing Environment, where we share information across platforms from private sector liaisons that work within emergency operations centers in states around the country, and also the private sector organizations that they provide information to and share back and forth so we can make sure commerce gets distributed across the country, power gets restored quicker, and prescription medications make it into all the pharmacies around the country safely. So this is a different look from the tropical view. This is actually the water vapor view right now, and it looks like Hurricane Rafael is pretty intense still right now, just below major hurricane status. It's a Category 2 hurricane, winds of 110 miles per hour, but you know, on this water vapor, this is called a water vapor image in the GOES satellite. We can look at different levels in the atmosphere. So this is upper level of the atmosphere. We can look where the moisture is. And typically around hurricanes, we have a lot of moisture. And the hurricane looks a little bit more concentric when it's not trying to fight dry air. And that's what's going on. Always a fight inside of the atmosphere with dry air trying to win over moist air. Dry air likes to eat away at that moisture, and you can see that happening here along the southern portion and eastern portion of the hurricane. Now, Rafael still remains over warm enough water where it's able to fuel the growth of the storm, or at least maintaining the storm. It was Category 3 overnight, winds of 115 miles per hour, but it's decreased a little bit. The Hurricane Hunter aircraft from the U.S. Air Force Reserve have been flying through the storm, and it has detected that it's weakening just a little bit. Hey, it's great news when these storms weaken. I know everybody along the Gulf Coast gets very nervous when a hurricane enters the Gulf of Mexico because most of the time it has to make landfall somewhere. Well, it just so happens that the weather patterns right now at this particular time are not conducive to turning the hurricane northward so it will make landfall. That's really excellent news. And what do we have to thank for that? We have this big storm here. This is a big low pressure system over the Four Corners area. Well, it's really clobbering northern or southern Colorado and northern New Mexico with heavy amounts of snow, several feet of snow in the higher elevations, even Denver, very snow covered right now. A lot of trouble driving on the roads with intense snowfall. At the same time, we have a tropical monster going on, this Hurricane Rafael that is sort of meandering now. Let me take you a little bit closer with the 1 meter or 1 minute satellite imagery. This is Rafael in all of its glory here, but look at this. It's like here's the center of the storm, but in the northwest and western quadrant, it's a very intense hurricane. The winds are still strong around the center, but look at the dry air kind of eating away at the clouds here, not making it a very good presentation on satellite imagery. And we can use satellite imagery to determine the strength of a hurricane, and then we validate that estimate through the Hurricane Hunter aircraft that fly through there and take those measurements. That is a job that is occupied by heroes, ladies and gentlemen. They risk their lives every day. They fly into these storms, risking a lot of turbulence and severe weather. So this is what the storm looks like. Let me take it full screen here, and then we can show you the current stats for the storm. Right now, it's located 24.5 north, 88.8 west. Not really moving that much, only west at 9 miles per hour. Here's a point of reference, 535 miles east of the mouth of the Rio Grande River. I'll show you that in GeoCollaborate. It's about in the center, almost in the center of the Gulf of Mexico, and it's going to do a little dance, and I'll show you what I mean about that. Pressure at 961 millibars, and the max winds 110 miles per hour. I think that's going to be going down now. I don't really think that we're going to see a whole lot of intensification of Rafael. We might see the status continue for several more hours, but I think that the dry air is going to win out and start to decrease the intensity of Rafael over the next several days. And so we're looking at Category 2 hurricane, but it still remains a very strong hurricane, a powerful hurricane. And the one thing it's definitely doing is kicking up the waves. Remember what we did yesterday? We showed you the wave drifters, the Scripps Oceanographic Institute, working with NOAA, dropping these spectral wave drifters. Well, let's go and look at GeoCollaborate as far as the full screen goes. Now, here we go. This is GeoCollaborate, so I have complete control of the map here to zoom in and talk about a couple of data points that we have here. Let's get a little bit closer. This is the initial Windfield, so it's a fairly compact storm right now. Remember when Milton made landfall in near Tampa? The Windfield expanded. It was a very large Windfield, pushed a lot of water into southwest Florida. A lot of storm surge there. Helene was sort of the same thing, had a very large Windfield. This one, compact. So hurricanes, they come in all sizes, all shapes and sizes, and they have different impacts depending on the direction that they move, where they do make landfall or don't make landfall, and the size of the wind field. This is really critical. So this area here is the tropical storm force winds. They extend out here. These are the storm force winds, about 50 knots or 55 mile per hour winds. And then in the center are the hurricane force winds, 75 miles per hour, all the way up to 110 miles per hour at the current advisory. And I can click on this to see when the latest advisory was given from the National Hurricane Center. This was at 10 o'clock Eastern, 9 o'clock Central, 110 mile per hour winds, gusts to 130 miles per hour. I think that's about the max intensity we're going to see now through its lifetime. And boy, when was the last time you saw a cone look like this? This is showing the likelihood that the center of Rafael will remain in this cone for the next 5 days. And that's good news because look what it does. It moves this direction, moves a little bit further north, and then comes back and does a loop, and then gets driven down to the south. And by this time, it's a tropical depression, kind of dissipating, we call it, into a remnant low. It's just going to be spinning around. Maybe in several days, we'll show you a visible satellite picture of just the low-level cumulus spin of these clouds that don't have any more thunderstorms or intense rain associated with them. It's quite fascinating to watch these storms in satellite imagery evolve and devolve into remnant lows. But you can see it's forecast to be a hurricane here with 80 mile per hour winds. That's during the day tomorrow at 6 a.m. So we're on the downward trend now of intensity. May see the wind field expand just a little bit. And then tropical storm in this area, and then just hovering around all the way through Monday, and then down here becoming a remnant low on the 12th. So today's the 8th. So that's Tuesday, the 12th, remnant low. So we'll keep telling you what's going on with this storm because it is having an impact. It's having an impact with the generation of waves. So let's take a look at some of these spectral wave drifters from Scripps Oceanographic Institute and NOAA. And this is really helping us because the Air Force planes fly through the storm and they can get winds and all that stuff, but they can't measure the waves. The NOAA Hurricane Hunter aircraft, they have equipment on the airplane that can measure or estimate the waves based on energy pulses coming out of that sensor and then coming back up. So Kaya is one of them, WSRA is another, and then we can validate those wave heights by clicking on these spectral wave drifters. Now look at this one. This is 11.8 feet, 11.8 foot waves right now, and that is 3.59 meter waves. The dominant wave period shows you 9 seconds. The mean wave period, 6.5 seconds, or 6.55 seconds, and a dominant wave direction of 4.8 degrees. That means basically almost north. And why is it coming from the north? Because this is what's generating those waves. The strong winds around the hurricane pushing the waves this way, outward. Now let's take a look at this one here. 16-foot waves happening right now near the storm, 4.88 meter waves. And look at this direction, 49.7 degrees. So that's almost 45 degrees, but 47 degrees. The waves are coming because the winds are coming around this way and pushing the waves out. So we can tell the angle that those waves are coming. This is really important. Now let's move a little bit further away and let's get the coastline in play here so you can see what's going on. So here we have the hurricane, pretty compact, but here, look at all these spectral wave drifters. And this one doesn't have the wave reporting turned on, but this one does, I believe. 5.3 feet. This was earlier, so the storm was a little bit further away, so we can see the time of this observation. This is actually last night at about 10 o'clock or so. But look at this one over here. This one's more relevant. 4.9 foot waves, 1.5 meter waves. So 5 foot waves out here that are propagating towards the coastline, moving towards the coastline. How about this one up here? This one, 13-foot waves. So this storm is generating a lot of swell and a lot of waves that are heading towards the coastline of Louisiana, Mississippi, Alabama, and even back here towards Florida. These waves, 10.5-foot waves that are being recorded by these spectral wave drifters, 9.7-foot waves. So it doesn't mean that when all of these waves, just envision them spreading out from the storm towards the coastline. They're not going to maintain that wave height, but the energy being released by the hurricane is pushing these waves outward. That is why we have coastal advisories around the entire Gulf of Mexico, basically, and that is for rip currents. We have rip current advisories. We have small craft advisories here, advising small craft not to go out because of those wave heights. And we can tell those wave heights because of these sensors. I can turn on the NOAA sensors as well, the operational NOAA ones. These spectral drifters, that's from the research side of the house, not the operational side of the house. But I do want to turn on the ocean observations that the NDBC, National Data Buoy Center, has in the Gulf of Mexico. And it looks like there are a ton of them here, but look, these are all oil rigs that are out here. Yes, there is a lot of drilling going on in the Gulf of Mexico, but some of them have weather sensors on them. Others don't report much weather data from these oil rigs. Here's one right here. This is operated by the FAA. Shows the air temperature, the wind, 26 knots. So it is a breezy day because there's a hurricane to the south. Visibility 8.7 miles. And it just shows the latitude and longitude for the location. So let's click on a couple of NOAA wave. You can see the waves going up and down here, the column of water going up and down, and you can deduce the wave height from here and see more observations by going right to that buoy location. Let's take a look at this one here. Here's one, northeast winds gusting to 31. So this is really interesting. We can dive down here a little bit and look at this. So this is the radius of maximum winds that is starts at 39 miles per hour, tropical storm force winds. But this buoy is outside of that. Winds gusting to 31, 25.3 knots. How do you think NOAA and the National Hurricane Center helped to identify the radius of maximum winds? Yes, number one, through the airplanes, but also through buoy measurements. So if we can take a look at this, and if this one was reporting winds of 40 miles per hour, this radius of maximum winds would be larger, but it's not. Here's another one down here in this direction. I'll just pan up a little bit. This one is reporting wave heights of 4.6 feet. And you can see the winds gusting to 7. So no influence from the hurricane there. It likely will when it becomes a tropical depression. But let's check out some of the wave heights over here towards Florida and see if any of these are reporting particular wave heights. This one is not, but it does have water temperature of 79. This one a little bit closer has a significant wave height of 3.3 feet. So that's not too bad. But the energy being released from this storm in the Gulf of Mexico is generating waves. And I do want to just make a point that when you go to the beach, this is for all of you who might be going to Texas or Louisiana, Mississippi, Alabama, Florida beaches, just remember that this storm can generate waves that break on the shore. They're called shore break waves, and they can cause serious harm. So you really have to know the sections of the beach that you're approaching, watch those waves and what they're doing, and please never turn your back on the waves. We have a little video update here from Bruckner Chase and NOAA on how you can stay safe at the beaches.
Any breaking wave can be dangerous, but a wave breaking directly on a steep shore, like this one, is even more likely to cause serious injuries. These conditions are called shore break. Why is this type of wave so dangerous? Imagine the weight of a car pushing down on your head, neck, or back and pinning you against the sand. That is the impact a shore break wave can have and change your life forever.
We love all of our coastlines, and we want you to have a lifetime of great beach experiences. To have fun and stay safe, always respect the power of the ocean and be wave safe.
We want you to stay wave safe. We certainly do. And this is a look right now at back at GeoCollaborate, just along the coastline. I'm going to turn these buoys off from NDBC. I'll leave the global drifters on here. But anybody going to the beaches around the Gulf of Mexico, please exercise caution. We want you to enjoy it, but we also want you to stay safe. Now, I'm going to show you something else too, and that is the rainfall rates. Remember, I showed you this before. I'm going to turn on the legend here so you can see what's going on. This is very, very interesting. This is from NASA and a whole bunch of other satellites that NASA's pulling in to create estimates of rainfall rates. Now, this was yesterday when Rafael, look, there's some of the spiral bands of Rafael, was moving into the central part of the Gulf. These are the rain rates that were still being experienced yesterday coming across Cuba. Even though the hurricane was way out here, the moisture fetch coming across Cuba was still generating rainfall rates about 1.5 inches an hour, causing continued flooding. And there was a lot of damage across Cuba when Rafael came across there as a Category 3 hurricane. But I also want to point something else out. There was a tremendous amount of heavy rain and flooding yesterday in Georgia and South Carolina, and that caused flash flood emergencies and just a tremendous amount, record-breaking rain in some areas of Georgia and South Carolina. This is how NASA satellites saw the rain rates happening. So, and this is over a long period of time here too, anywhere from, 1/2 inch to more than 1 inch an hour falling. Very intense rainfall rates. And when that water has nowhere to go, it just builds up on the streets, low-lying areas. So a lot of people are assessing the damage right now from heavy rain and flooding rains in Georgia and South Carolina. Meanwhile, over here, we have that big intense storm over the Four Corners area generating a lot of snow. This is estimated snowfall rates. And look at that kind of banding feature that was showing up yesterday in the radar data. So Colorado and New Mexico, even out into the foothills of Colorado, western Kansas, there's a lot of snow, folks. Yes, it's November. We have this snow going on, and we have a tropical system happening in the Gulf of Mexico. Now, I'm going to turn on the sea surface temperature anomaly data as well, because I do want to show you those anomalies, and I'll turn off the rainfall data so that doesn't get too distracting, I guess. So this is what's happening here and I'll take the legend off, with the sea surface temperature anomalies. You can see this going on. There's some below average and some above average. Look how warm it is along the Texas coast and Louisiana here. That is very, very warm. Let me put on the legend for the sea surface temperature anomalies. This goes all the way up to about 3 degrees or more Celsius above average. So this is very warm here. But you also see pockets. And this is updated every day. So we can see the influence, I think, here of Hurricane Rafael kicking up some of those cooler waters from underneath in the Gulf of Mexico, even though the ocean heat content is pretty good with warm water at depth. When you have a slow-moving hurricane, it's going to kick up a little bit of cooler water. Doesn't mean that it's not going to support the hurricane, but it's just cooler than average. But look at all the Gulf of Mexico that is above average. And so this is pretty amazing that we can monitor this and update this every day with a combination of satellite data and also model data that we feed in there. Okay, well, let's talk about the forecast now, because everybody wants to know what's going to happen with Rafael and the official forecast I went over with that cone of uncertainty. It is expected to dissipate next Tuesday into Wednesday in the Gulf of Mexico. And I want you to see what's happening with this moisture. So this is the GFS model, the operational model, and it's still keeping moisture down in the tropics. And we're going to have to keep monitoring that because this particular model wants to develop yet another tropical system in the Caribbean. So you can see Rafael. Rafael is right here. And I'll take this model forward, and we can see where Rafael goes. It just kind of meanders in the Gulf of Mexico here. And then it starts to weaken. But notice the moisture from Rafael does stream up into the Midwest and starts to add to some of the rainfall intensity. So in some cases, there could be very intense rain because we're entraining tropical moisture. We're mixing tropical moisture into the mid-latitude system here that's over the Rockies, and then sort of spinning energy out. High pressure still trying to dominate along the East Coast and ridging down the coast here. That's called damming. It's when the cold air comes to the east side of the Appalachians, can create pretty good snowstorms in the winter when they develop along the coast. But this is Rafael, and we'll watch this dissipate in the Gulf of Mexico. And you see it now move down to the south. And you see now that this is Tuesday night. November 12th, in Z time, 0Z, November 13th. But Rafael is all but kind of that remnant low. But look down here in the Caribbean. The Caribbean is still warm enough. And if conditions are right, we could have the development of a tropical system. And that's what the GFS wants to do. Again, we're out here at hour 108. That's right on the borderline here of fantasy land, but I'll take it a little bit closer, a little bit further here, just to show you why we're going to keep paying attention. We're going to keep paying attention because out here, hour 228, which is way out there, I don't particularly believe it that much, but we'll keep monitoring the model runs for consistency. You see it does develop another tropical storm and or a potential hurricane here that moves up across Cuba into the Gulf of Mexico. So we'll be watching it very, very closely. Don't want to get anybody on edge of their seats. We're going to do this the same way we've done all of the storms in the past, and that is to monitor the development and monitor the whole synoptic situation. That means where these big highs are, where lows are, where big troughs are coming in across the country that could influence any further development. Heck, even some systems have developed in the Caribbean and moved directly eastward and back towards Africa at times. So we'll be monitoring it. And I just wanted to call your attention to what's happening with this model forecast. And so we have sea surface temperature anomalies. If I go down into the Caribbean, we have a lot of warm patches here. We have some that are about average, maybe a little bit below average, but there is a lot of warm water and a lot of fuel that's happening in the Gulf of Mexico, or not the Gulf of Mexico, but Caribbean Sea and parts of the Gulf of Mexico as well. So I'll take you back here to the water vapor satellite image where we can see the moisture moving all around the country. And that's that red and orange area there, by the way, is dry air being pulled up. And there's a lot of dry air that this Hurricane Rafael is going to be moving into as well. So we can hopefully bid good riddance to Rafael on Tuesday or Wednesday next week, but please just be careful if you're going to any of the beaches. That's it for this tropical update on this Friday, November 8th. I'm Dave Jones with Storm Center Communications and GeoCollaborate. We'll be updating this, uploading this to the SISE Hub, and also sending it out through the Signal app. Thanks so much for watching. Please enjoy the weekend. I'll probably have another update, a shorter one, promise, tomorrow, and probably around noontime or so. Maybe later in the afternoon. We'll see how Rafael's doing. But please take care of yourself. Watch out for your neighbors. They really do appreciate it. Thanks so much for watching. We'll see you tomorrow.